Physics. I'm going to apologize ahead of time because the math part's pretty easy, but there's some notes. By notes, I mean a lot of notes. So anyway,
Oh
let's start
no.
with this. Oh, yes. Ugh. I was gonna ask Ada, if you work, would you coach, right? Like, do you get paid for coaching or is this a volunteer gig?
Yeah, I get paid like more than $20 an hour.
Holy. Do your
Yeah.
sisters hate you out of jealousy?
No.
Like, even if Maya got paid well, that I imagine would be like 15 bucks an hour.
Yes, I'm jealous.
How much do you get paid, Maya?
Like $14 an
Yeah.
hour.
So like that's good, in like for that type of work and everything, but it's not stinking $20 an hour.
I know, right?
Moly. I made minimum wage until I was a teacher. Every job I had, like I worked jobs that got tips and everything, but it was minimum wage. And when I was your age, yeah, I'm gonna pull that card.
I hate when people
Minimum.
say that.
I hate hearing it come out of my own face. Minimum wage when I was like 17, 18 was like $5 an hour, man.
Ooh.
Granted, gas was closer to, okay, never mind. Who cares? I'm old. We all know that. I don't need to age myself even further.
You know, I write a lot slower when
I
we.
know. And then that's, I was thinking, I need to not ask you questions because then you can't do two things at once. That sounded like an insult. It's not. Only Ada wasn't listening to me talk. We'd be done already.
I just finished the title.
Crap. Okay, I'm not saying anything.
I'm not even kidding.
I believe you. I'm gonna go for a walk. I'll come back in 20 minutes.
Sometimes my parents overhear these videos and ask why I get picked on so much.
They don't think I'm being mean to you, do they though?
No.
Okay, good. All right, just checking. Okay, so hearing that, I'll say because you deserve it. There. That's funny. What was that?
It's my electric sharpener.
Holy moly. Sound like an old printing press firing up or something.
I don't like the mechanical ones, so I just use the regular ones at home. But I like a sharp pencil, so I just sharpen it too many times. It's really annoying.
I can understand that. Sharp pencil is satisfying.
I just put myself on mute.
Your sister's addicted to shopping, and you're addicted to sharpening your pencil. It's probably the safer addiction. Maya's addicted to giving other people bread. That's my favorite addiction.
Exactly.
Receiving bread. Who says no to that? An animal.
She makes me carry it everywhere. The big bins. I'm almost done.
Okay. I'm doing my best not to respond to you, but it's hard.
Same here. Okay, I'm done.
All right. Efficiency. Sometimes the big note to make here with efficiency, and this is a fraction as normal, so it's E out over top of E in, and then it's that answer times 100% because you're going to get a decimal. There's no units because it's joules over joules. They cancel. If you're not sure, if you're like, oh man, I don't know which one to put on top, which one to put on the bottom, the top one's always going to be the smaller one because you can't have more than 100% efficiency. So if, oh, this part is 50 joules and this one's 25 joules, 25 goes on top. Because if it's 50 over 25, you'd have 200%, and it's impossible. Like legit impossible. Not, it's impossible to touch that ceiling. Like, no, it's impossible. So we're gonna do the tutorial right now, and then we'll just, do 24 pages of notes after that. So, full screen, all right, here we go. It's funny, Ada, when you talk about the pencil, because when people will come into my office, like staff, often I'll be working with a pencil and they're like, why aren't you using a pen? Like people get weirded out by it. It's like, I like to, especially if I'm doing something creative, if I'm trying to, whatever. Pencil just feels better. Okay, page 243, number 1, it says a forklift uses 5,200 joules of energy. So energy, and it's using it, so this is energy in 5,200 joules of energy to lift a mass of 50 kilograms to a height of 4, h equals 4, to a height of 4 meters at a constant speed. What is the efficiency of the forklift? So the efficiency, 5,200 joules is what it's putting in. What is it getting out of it? And this might seem weird. Well, it's got M and H. Well, if you think of potential energy, gravitational potential energy, that's Eg equals mgh. So we can figure this part out. The mass is 50. Gravity is 9.8. The height is 4. So that's 200 times 9.196. That's 19,600, I think. But let's check. 50 times 9.8 times 4. Oh, too big. 1960. So 1960. So this is basically, it's lifting up this, what is this, a car? No, it's just a mass, a car, 50 kilograms. So it's lifting it up higher. So now it's got this potential energy. So basically, the energy that's going in is the 50, the energy that's going in is the 5,200. And so that's what goes on the bottom. The energy that we're getting out of it is 1960. So it's whatever that is times 100%. Maybe I should do the actual formula here. So E out over E in equals 1960 over 5,200. 1960 divided by 5,200. So it's 0.3769, blah, blah, blah. When we multiply it by 100%, we're kind of adding the percent as our units, if you will, and we're moving the decimal place over twice. So times 100. So it's 37.69 or 38%. So efficiency equals 38%. This doesn't feel as clear as it should be. Don't like that either. Looks a little better. Does that make sense? Any problems? Well,
so how would you word the answer? Like it's a 38% efficient?
So it says, what is the efficiency of the forklift? You could say that the forklift is 38% efficient.
And what does that actually mean?
If you want like a more fuller sentence, the forklift is 38% efficient in the transfer of energy, or in the energy conversion. Because it's using the energy that it's using is chemical. It's mostly chemical. I suppose it's kinetic as well because it's burning the gas the diesel, I imagine, to exert this force to lift this mass. And then once it lifts, let's say it puts it on the shelf. So it lifts the mass, puts it on a shelf. Now that mass is just sitting there with potential energy that could potentially fall, and then that energy would be converted, etc. But so it converted 5,200 joules into 1,960. Does that make sense?
Yeah, so that's the ratio, and that's how we find the 38%.
Exactly. It's a ratio. That's good. It's
Okay.
good that you said that word. That's why, yeah, there's no like this is the units, it's just a percentage.
Okay.
It's like when we're talking about mu, there's no units, but we have it as like as a decimal. If we wanted it, we could write that as a percentage. We could say it's 46%. It's the same thing.
So it's the ratio of how much goes in and comes back out.
Yep. Yep.
So if 5,200 goes in, only 38% of that comes out back out.
Exactly. You're going to get questions that are exactly like that. If 5,200 joules was put in and it's only 38% efficient, then how much do you get out? Exactly.
Okay.
Cool. What is that?
I thought we were gonna learn that. I'm like, what is that?
Oh, you know, that's actually really funny. You know what this is? When kids, like sometimes, you know, last test of the year and stuff, and kids don't collect them, they don't want the back, whatever. I use scrap paper. I hate wasting paper. You know whose test this is? That did that work on the back? You know whose that is?
Whose?
Maya Ehler.
Really?
That's pretty funny. Okay, number 2 says a tow truck attaches a cable to a car stuck in a muddy ditch. Oh, it's really painting a picture for us here. This friend of mine, oh, okay, do you want to hear a quick story? I'm going to tell you. This friend of mine, she, her car wouldn't start yesterday. So the CAA guy comes and helps her out. And then she says, he was really cute. Is it bad if I call the office and ask for his phone number? Is that harassment? I was like, no, you're just asking for his number. Like, do it, man. You know, like that's nice. That's a, you know, she's not a creep, so she's not going to be creepy about it. If they give you the number, that means that, you know, he wants you to have it. If not, move along.
Gotta do what you gotta do.
Gotta do what you gotta do. And she said he was a really nice guy and didn't talk down to her, and that's good. That because guys can. Anyways, moving along.
This Zoom is gonna take hours.
Yes, sorry. A tow truck attaches a cable. It made me think of another story, but I'll save it. A tow truck attaches a cable to a car stuck in a muddy ditch. The 1,250 kilogram car, so the mass is 1,250, is pulled up an embankment to a height of 1.8 meters at a constant speed. The cable exerts a force, so the force equals 5,500. I don't have these things labeled yet because I don't know if I'm going to have to differentiate or not yet. Cable exerts a force of 5,500 over a distance or displacement of 12.6. Okay, lots of information. What are we going to do with this? What is the amount of useful energy produced? Okay, so basically, we've got a car that was dragged up and out of a ditch. It was raised 1.8 meters. So the useful energy that's created is the gravitational potential energy. So this is part A. Gravitational potential equals mgh. Mass is 1,250. My friend's going to hate that I told you guys that story. G, although how's she going to know? Oh, I know, because I'm going to tell her. Height is 1.8. I'm going to say that we're all cheering her on. She's great. She's one of my favorite people in the world. If I've ever told you guys about a story where me and this girl on opposite end of the rooms pointed at each other and were talking about each other, that was her. We were both said the same thing. I was talking about her. I said, I wish she was my sister. And she was pointing at me, talking to somebody else saying, I wish he was my brother.
Wow.
Yep. She's good people. So the energy created is 22,050 joules. I guess we need a sig fig answer. So that'll be 22,000 joules. And if all those zeros is hard to write, 22 kilojoules. This is the energy, excuse me, the useful energy produced, not created. It's very careful in saying not created because energy is not created or destroyed. It could also say the useful amount of energy converted, but does that make sense? We're okay so far?
Oh, why did you use the gravity energy? Like
Um,
why?
because there's two kinds of energy that we are aware of, like as far as kind of what we're using. It's either kinetic or potential. Kinetic is mv squared. It didn't give us a speed or anything. Wasn't talking about that. It fairly clearly told us that it's potential because it pulled this car out and just brought it up here. This was the distance, which means it stopped moving. Does that make sense? Like it kind of painted the picture that it pulled it, dragged it out of a ditch. It gave us a distance this way, but it also gave us the height and the mass. Does that make sense?
Okay. Yeah.
If there's a little bit, there's always with physics, there's always going to be a little bit of figuring, and it's like, is this point important? Is this point not? And so it's that kind of thing. It won't always be super duper clear. Anybody else? Thank you for asking. All right, then I'm going to move to B. And part B says, what amount of energy is used to pull the car from the ditch? So in this case, notice it tells us, it gives us the force and it gives us the distance. What do we know about force and distance? What does F times D equal?
Work.
Work. What does work equal?
E.
There you go. So that's what we need to do is do F times D. So FD force is 5,500. This is 12.6. It's going to give us our work. So 5,500 times 12.6, 69,300. So work, which equals energy, equals 69,000 joules. I meant to write 69. I'll do it here. Equals 69300. But this is our sig fig answer, or 69 kilojoules.
So I don't understand. Oh, wait, never mind. I was just going to say in my mind, the question, like if I saw it, I would just assume that it was talking about like the force it took. But
Yeah,
it's force over distance because it wants the joules, not
yeah,
like it wants the work, not the force that it took.
yeah. It's asking for the amount of energy, correct? Yeah. And so now, efficiency. So the energy that we got out of this is the 22,000 or 22,050. The energy that was put in is 69,300 times 100%. So it's 32%. You know what we could do? Well, I'll just wait till we're done this. Is everybody okay with this?
Yep.
Silence, I think, means it's good. Just probably thumbs up. Okay, so what I was going to say we could do, I'll just show you, because we could end this now and I could just send you the notes. But there's probably some things I want to talk about. Okay, so what page are we? Where are we? So this? Yeah. Okay. So look at this. If you can see the side of the screen. We have 1, 2, 3, 4, 5, 6 slides of notes. So what I could do, if you guys want, if you prefer, is because like there's stuff I can talk about, but it's all right there, and there's references on pages to look up. I can just send you these notes if you want. Would you prefer that, or do you want to sit here and record them and then ask questions as if they come up?
I mean, as much time as it takes for me, it's better to be able to ask questions.
Okay, that's cool.
The others.
And yeah, and so if Nathan and Kate, it is almost literally just notes. If you want to bounce, you can, but if you want to stay, totally cool. So let's go through the notes. Whoosh. So Ada, if you can just let me know when you're done each slide, and then I'll add whatever it is I want to add.
Okay.
Pretty please. Don't say anything inappropriate. They're recording.
Yes, favorite one.
You can say that part louder so they know. What up, dog?
I need you to check something for me.
Hang on. Hang on one sec. Hang on. Oh, I don't know how to mute this one. I'm screen sharing.
You have a second? Like you're literally recording?
Yeah, like kids are taking notes. What, like you need to come with you?
Yeah.
Okay. Next slide I will.
2 minutes.
Yep, next slide I will.
Okay.
Because I'll have time. Because Ada takes 25 minutes to write 5 words. So. You know why he laughed? Because it's true.
I've never had Mr. Enns as a teacher.
Lucky you. From what I hear, nobody likes him. He's way too short, and then lots of other things.
You're getting me to mess up on my notes again.
Sorry. There's a guy in my first year of teaching. The guy I got along with best. He was great. Really liked him. I found out kids hated him, but it's like he was my favorite person on staff. Kids hated him. It's weird. But no, Enns is a good dude. Mostly. He is short. I shouldn't say stuff like that. But it's not like he doesn't know.
I'm almost done.
These recordings are gonna get me fired before I can quit.
I'm done.
No one device is 100% efficient. So if you're figuring out efficiency and you get over 200%, you got your numbers switched. The thermal energy part, that's a decent test question. That's why you'll see heaters. There's going to be a table on page 244. Heaters are very efficient. An electric heater, 98% efficient, because usually heat is wasted. But if the heat is the goal, then it's working. All right. Do have a look through page 244 at some point, but not now because you have notes to take. I'm going to go see what Enns wanted, and I'll be back. I know I can take my time. Kind of. Ada, did you finish writing down energy sources?
Yes.
Not a girl. How do you, shooter? Are you done? You're not done the whole thing yet, are you?
No, I lost my spot.
Sorry. Judging by your tone, it's my fault.
I'm done.
How do you? There's a lot there. I'm gonna go warm up my lunch. I'll be back.
Guys, am I a lot slower than you with taking notes? Or are you like right behind me?
You're not like super slow, but you're slower than me.
I'm trying not to like take up your time. I'm trying to write fast.
Where you at, Miss Ealer?
Third paragraph.
Cool. Let me know when you're done. Pretty please.
I'm done.
So there's the bits there about nuclear energy. You'll see and hear and read like nuclear energy is the cleanest, most efficient, strongest, et cetera, et cetera, et cetera, until it's not. Like you've, if you haven't heard of Chernobyl, you've definitely heard of what happened in Japan not that long ago. I'm not talking about the bomb, but when they, with the tsunami and everything, and then the fallout, and they're still dealing with it. This is, I don't know, 10 or 12 years ago. There's something in the news recently about releasing some of the radioactive water into the ocean. They're arguing the pros and cons of it. Like it's crazy. But just to get an idea of the power, like when it's talking about splitting, if you guys remember, when we were talking about forces, it was our third unit. If we can assign like gravitational force, if we can assign a strength of 1 to gravitational force, just as a relative comparison, 1, then a strong nuclear force is 10 to the 38th power stronger. So that's a 1 with 38 zeros. A billion is 9 zeros. So nuclear strength, force, power, however you want to look at it, is incredibly strong, which is why so much energy is released when you're able to split the nuclei of different atoms. Fusion, which is even more powerful, is what goes on the sun and has not been able to be replicated on Earth. So there is lots of power there. It's just, when things go bad, they go really bad, and they go bad for a long time.
So the first one, is that like an atomic bomb type thing?
It can be, yeah.
Like when you split an atom?
It's kind of a chain reaction. In grade 12, there's a really cool diagram. I have a grade 12 text here. Well, I'll see if I can find the diagram while you guys are doing the next page. It sets off a chain reaction. So there's different clusters that go off. So it's still like it's sizable. It's not one atom per se, but by sizable, like, a nuclear bomb the size of this room would take out, half of Vancouver Island, kind of a thing. Like massive, 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 massive power. So yeah. Other questions? All right, I'm gonna find the next slide and see if I can find this picture. What the heck? Did we miss yours? Oh, it is this year. We can get to it. Yeah, if there's time, if we can fit it in, we'll be doing like nuclear decay and chain reactions. I'm going to interrupt your notes for a second just to show you this picture. So it's a series of nuclear reactions that start by splitting this uranium. One neutron is thrown at this uranium and then splits off. You got barium, you got krypton, more neutrons go, they split up more uranium, gives strontium. I don't know what SB stands for, I don't remember right now, and so on and so forth. It's just this crazy chain reaction. So just to give you a little bit of a picture to put with the idea. Yeah, it's pretty wild, man. Technology is insane. There's a lot of people that are very, 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 very smart. Like, it's fascinating to me how these things start when people first discover what things do. The guy that discovered, I don't know if I told you guys this, that discovered gravity, like not discovered gravity, but how gravitational pull works just based on mass, had these two huge lead balls. I don't know where you get those. Like, this is like 1800s. He had them in his backyard, in basically a shed in his backyard, and he hung this thin wire between them that had a mirror on it, such that the pull between those two massive balls would twist the wire, would change, so a reflected light would change its angle, and basically him working through this could figure out gravitational constant of 6.67 times 10 to the negative 11. What's also interesting is looking him up. He was most of these guys are rich, you know, they can afford to have the time to do this stuff. He had servants, but they were female servants, and he was too nervous to speak to women. So the parts of his house that they lived were sealed off. They would pass notes underneath the doors because he wouldn't talk to a woman. It's just fascinating in the weirdest of ways.
Is it weird to have no response, like when you're talking and everyone's on mute?
Oh yeah, I hate it,
Just get used to it.
But it is what it is. Yeah, just is what it is.
Sometimes I'm like laughing or like responding, and then I notice I'm on mute, and I'm like,
Yeah.
oh.
Last year, Gavin, he would always feel bad. So anything I would say, like there'd be a pause, and then he'd go, "Okay," like he wanted me to know that someone was listening.
That's funny.
Nice guy. But I get it. That's just the way it is. I don't take it personally.
I'm done, by the way.
Okay. It's like I said in math a couple of days ago, maybe it was last week. All of a sudden I could tell when I lost the room. I'm talking about something and people aren't understanding and they're a bit lost. I can see it in people's eyes. When it's online like this, I have no clue.
Yep.
So last year when it was mostly just recording, wasn't anything live, that was the worst. So hydroelectricity, like this is dams. It's just the running water that's doing the work.
How effective are dams?
Like efficient?
Yeah.
I think there's a chart. Let me just look it up. 80%.
Oh, wow.
Pretty good. See, and the thing too, a nuclear power plant 30 to 40%. And you're thinking, well, that's not super efficient. But the amount of energy that you get is
Yeah.
crazy.
I'm done. I feel like I'm the only one who ever talks.
Well, sometimes I get some chats or like the little emoji things you can do with the thumbs up and stuff. So there's nothing wrong with it. I appreciate it. I hate just talking to a screen, but I get it. Like I don't want to guilt anybody about it. That's why in staff meetings, I keep my camera on. Most staff don't, but I just know what it's like just talking to a blank screen. It sucks. So if I'm in a staff meeting or something else, I keep my camera on so they know they see a human at least to react to. So even if I have only like one student kind of online for a class, it gives me someone to talk to. I sound like I'm in solitary. I'm just happy for a visitor.
I'm done.
Then we're done. Any questions from anybody? Then you are free to go. Oh, I forgot. Can you see me right now? Like, do you guys have a little window of this?
Yeah.
Yeah.
Because I normally have that minimized. I just hope I'm not doing something stupid. Probably not. It's just looking through pages and stuff. So it's like, it'd be really dumb if I had it like sitting like this and not know, sitting here talking to myself.
It's like the tiny little icon on the side.
Yeah. Oh, all right. Okay, you guys have a lovely evening, and we'll see you later.
Wait, Mr. Morris, am I supposed to stay behind and?
Goodbye.
Bye.